All right, so let me say good evening to everyone again here. Good day from any part where you're watching me from. I could remember that the last time we had class, we talked about sound, and we're able to check one or two things about sound in physics. So we have to move fast today. I just want to say a bit about some of the topics we are yet to cover. Hopefully, I believe you are reading well on your own too. It's a very wide syllabus. So we will just do our best to give you some necessary assistance and push forwards or push ups that is interesting for you to note. We've discussed light. I remember as I was discussing sound, because sound is a wave and light is also a wave. So there was a time I was just going in between to be able to give some basic interesting values. But today, I'm just going to quickly go through some basic ideas of the topics so that we can have some basic. Okay, so let me pick it from the very first measurement and scalars and vectors. Of course, we know all that. In physics, precision is of very high importance to us. So we need to measure. And when you are measuring, you know a meter is, all these conversions are necessary, as simple as they are. They test measurement in vernier calipers, measurement in micrometer screw gauge, even measurement in meter, in volume, in everything. So I need you to know that. And under measurement, we talk about fundamental quantities and we talk about derived quantities. Scalars are quantities that has only one reference of measure, while vectors are quantities that have reference in two terms of measure. You talked about measurement of size, and then you talk about measurement of direction, okay? The motion, of course, we dealt with motion extensively. I can tell you that motion was one of the things that took our time in this class, because we talked about linear motion, vertical motion, circular motion. We talked about projectile motion. Motion is very wide, all right? Then we talk about pendulum, yeah, pendulum motion, or what we call pendulum bob, with several examples. I could remember we dealt with that a lot. Then equilibrium of forces. I was able to explain what equilibrium of forces means. Forces need to be balanced. Forces need to maintain equilibrium, under the action of several of them coming together. Sum total of all forces acting on an object will be zero if those forces are added in the correct order, and that object will maintain what I call balance, okay? We talked about work, energy, and power, okay? Work, what work means. Work is the same thing as energy. Energy is ability to do work. Work is done when energy is consumed or expended. No work can be done if energy is not involved. So work and energy are measured in joules. When you work, it's as a result of the fact that you have consumed energy. So you need to know that, all right? Energy is force and distance moved in direction of the force, and work is also force times distance moved in direction of the force. So it depends on the way they ask the question, you'll be able to talk. And power is the rate of doing work. Power is work over time. Force times distance over time. That's power. Okay. And we have special reference of power. We have what we call horsepower. Okay. So you need to note all that. Then we talked about machines. Machines are, it means they are components that makes our work easy. You put in a little effort, it turns out to carry a very big load. That is machine. A machine can be in simple, formulas. In simple component like lever. Lever system is a machine. We have classes of lever, 3 classes of lever. you know a lever system. The lever system is a system or component by which you input efforts, and with the help of what we call fulcrum, a heavier load is lifted. That's what we call a lever system. Okay, we have three classes of lever. The first class is that load and effort are at extreme end and fulcrum is in between. Second class lever, you can give an example of first class lever as scissors. As scissors is a first class lever because fulcrum is between the load and effort. All right, effort is the round part where you hold. Fulcrum is that turning point where scissors blades are moving up and down. Then the mouth of the blade of the scissors is where the load is. Your own hand cannot cut clothes neatly, but when you handle scissors with that hand, the tip of the blade of the scissors will cut your cloth neatly for you. So that is first class lever. Then we have second class lever where fulcrum and effort are at extreme ends. Fulcrum and effort are at extreme ends, and then the load is in between the fulcrum and the effort. An example is your wheelbarrow. You carry the wheelbarrow at those two handles. The fulcrum is actually the tire, which is just at the other end, and then the pan in the middle is carrying your load. That's wheelbarrow. So it's a second class lever. All these things are very simple to analyze because they ask those questions and students still miss it. All right. That is first class, second class. Now, the third class lever, load and fulcrum are at extreme end. Effort is in between. Is in between. All right. Let me come again. Load and fulcrum are at extreme end. Effort is in between. Sugar tongue is a third class lever. All right. You hold it in the middle. The tongue is the load, then the fulcrum is at the other extreme end. You hold it in the middle. All right. That's to sugar tongue. You can write all these things down. Go on, YouTube, type first class, second class, third class lever. You see all these things with real images that you can appreciate. You can go on Google and download all those images. They are there. All right. You can read textbooks, you will see all these things there. So let's quickly move away from those levers. Let's talk about pulley system. The pulley system is arrangement of wheels. You must have seen that a lot in, maybe construction sites. Maybe I even have an example of pulley system. The road to my house is under construction, and there's a particular crossover bridge that they are trying to build. So the tractor is holding the pulley system. They are trying to dig a particular place, So all these things, arrangement of wheels that can make transfer of effort easy. For those who have what we call the wheels, where you use to draw water from the well, where you turn wheels, that's what we call a pulley system. It has its own calculation too. The number of wheels of a pulley system is equal to the number of efforts. All right. Then the general calculation, no machine part can give you 100% efficiency. No machine can give you 100% efficiency. The reason is because of the friction in between the parts. There's a friction in between the parts. When you see cars, with engine component and all of that, they don't give 100% efficiency. In fact, even with time, with use, the efficiency begins to drop. Okay, but they can give a high efficiency as much as 90, 95, 98. That's why you need to be pouring oil, several oil. Steering wheel oil is quite different from other type of oil. Brake oil is different. All those things just to maintain a high efficiency, and that does not guarantee 100%. Even at manufacture, no machine is 100% efficient. The reason is because of the friction. Frictions lower efficiency. Friction lowers efficiency. Okay, so you should know that the general calculation is load over effort, times 100%, or mechanical advantage over velocity ratio times 100%, whichever one, or work input over work I mean, work output over work input times 100%, or work input, all these things, you should be able to know it. Then let's talk about elasticity. Elasticity is the ability of a material to regain its original shape after it has been deformed, whether stretched, compressed, twisted, in any form. That's elasticity. I'm just trying to go through the topic and giving you summary of what you are likely to see. All right. All these things come with some detailed calculation we cannot begin to enumerate now. We've done some of it in the past, which has been quite well understood. So this class is just to summarize. And if at any point you have a question to ask me, please don't hesitate to interject so that I can attend to your specific questions. Very important. All right. Can you hear me what I said now? I want to believe you are.
Yes.
Oh, good. Beautiful. So like I said, I'm on elasticity now. So elastic materials are not only the one that can undergo stretch. You can deform it, you can compress it, it will still come back. So a spring is an elastic material. A spring, a spring is different from a string. A string is usually inelastic in nature. A string is usually inelastic, but a spring is elastic in nature. So you should know the difference by now. When you are talking about a string, you can talk about strings under sound, but spring under Hooke's law. It is this elasticity that leads us to Hooke's law, all right? And you know that Hooke's law says that if the elastic limit is not exceeded, the extension produced is directly proportional to the load, applied, or effort applied, as the case may be. So depending on whichever one, you remember that F is equal to KE, where K is equal to the constant of elasticity, E is the extension, while F is the force or the load that you apply. F is equal to KE. Don't forget that. Okay. Then let's go to hydrostatics. Under hydrostatics, we talk about liquid pressure or fluid pressure. We talk about buoyancy. We talk about Archimedes principle. All those things for a body to float on water. We talked about all of that. That is Archimedes principle. We also talked about, let me remember this. This is surface tension. Yes, that's what I want to remember. Surface tension. The ability of mosquito to walk on water without sinking is called surface tension. That is, the surface of a liquid behave as if it is an elastic stretched, curtain. That's what we call surface tension. Surface tension is also a product of viscosity. All right. The surface tension in petrol is far low than that of water. The surface tension in water is far low than that of oil, whether it's palm oil or groundnut oil or grease or any other kind of oil. All right. But that is oil in nature. Surface tension depends on the turbidity and viscosity. Turbidity is the presence of dirt. I don't want to use the word dirt. I want to use impurities. When you have a pure water, that one is clean. The turbidity is low. But when you have a water that contains mud, you won't be able to see through. That's what we call turbidity, where there's a lot of particle that is blocking light rays from passing through the water. Just like your pap solution, your paint, all those ones are turbid in nature. Just like I said earlier, the mud water is also a turbid solution, okay? Then we talk about temperature and thermal expansion. Temperature is the degree of hotness or coldness of a body. All right? Why heat? We'll get to heat separately, heat and vapors. Heat is that which raises or lowers the temperature of a body, is a quantity. Heat is a quantity which raises or which lowers the temperature of a body. But temperature is actually the degree of hotness or coldness of a body. So when really hot, that means the temperature is high. When a body is cold, that means the temperature is low. So you can remove heat from a body, you can supply heat to a body. It depends on the materials you are using. And then we talked about thermal expansion. There are three types of thermal expansion. We have linear expansion, we have areal expansion, and we have cubic expansion. All right. It also has its own, but there is a very important thing you need to know. Area expansion is 2 times linear expansion, and cubic expansion is 3 times linear expansion. Please note that. If your linear expansion is alpha, then area expansion is 2 alpha, and that's, let me call it beta. Beta is 2 alpha. Then your cubic expansion, which is called gamma, is 3 alpha. So by calculation, expansivity is equal to increase in length per unit length for each degree rise in temperature, which is change in length over original length multiplied by theta change or delta theta. Or some people will put it L2 minus L1 over L1 multiplied by theta 2 minus theta 1. So whichever one, I know you have materials, I know you have resources where you can get all this. This one is linear expansion. That's why you are using length from the word linear. If it is area expansion, you change all this L to A to mean area. And if it is cubic expansion, you change all the L to V, that's volume. All right, I've not written anything. I just want to make sure I wrote something on my board. I don't want my board to be blank all through. All right. So please pay attention to that. This one is about linear expansivity. And you know that majorly what they can ask you here is the application. Application of expansivity is very wide. Under rail construction, bridge construction, even your roof construction, there must be gap, because on a very hot day, there is expansion of metals. Metal expand, liquid expand. They will tell you about expansion of mercury, which is the only liquid metal. Mercury is the only liquid metal. All other metals are solid except for mercury. Mercury is a metal, and it's the only metal that exists as a liquid in the whole of your periodic table. Mercury is the only metal that exists as a liquid. Every other metal, unless they are melted, if they are not melted, the original state, they are solid. But mercury, in its original state, is a liquid. So note that. So they use different types of thermometric liquid. You use mercury, you use alcohol. Then you can also use, depending on, you can also use a metal. There are some metals that are good as, thermometric materials. All right. Depending on whether you are using electricity, you can use some metals. Their advantages and disadvantages are enumerated. Okay, let's quickly go to heat and vapors. Heat, like I mentioned, is that which raises the temperature of the body, is a quantity which raises the temperature of the body. When you supply it to a body, the body gets hot, the temperature increases. When you remove it from the body gets cold, the temperature falls or reduces. All right. And based on the arrangement, you can have what I call change of state. Change of state. I'm interested in this. I don't know. Maybe I felt like something is coming in this direction. You will always see this in your chemistry textbook, Ababio, for those who are using Ababio. Those are the textbooks we used those days. Liquid, no, solid comes first. But in any way, nothing, no, there's no special arrangement to it. We just like to put it this way. So this is solid, liquid, and gas. G for gas, L for liquid, S for solid, L for liquid. Okay. So the process is when a substance is moving from solid state to liquid state, you call it melting. You call it melting. You know all these things. As cheap as they are, the way they ask it in exams may confuse you if you are not used to it, if you are not conversant with this arrangement. So going this way is called melting. From solid to liquid is melting. Okay. From liquid to solid is called what? Freezing. Freeze. Not solidification. Some people say solidification. No, it is called freezing. Freeze. And that's why when you remember the word freezer, you won't have issue. That is the return journey. Going this way is melt. Coming back, freeze. From liquid to gas, it is called what? Evaporation. Liquid to gas is evaporation. Evaporation. That's how I will call just evap. Then coming from gas to liquid is called condensation. Condensation. Gas to liquid is condensation. Now here, please note, this one is called sublimation. Sublime. Sublime. From solid to gas is sublimation. And from gas to solid, some people call it freeze. Yes, it's possible for gas to turn to solid directly. Camphor, solid will turn to gas directly. Your camphor or camphor or whatever you call it in your house is a solid ball, but put it in any corner for long enough, it will not melt. It will just turn to gas. You just see that the size is reducing and you don't see water droplets. You don't see water droplet. That means it's turning to gas from solid. So we have sublimation. All right. I need you to note all this. Then we'll talk about molecular theory. And the molecular theory is talking about movement of molecules. Movement of molecules. Molecular theory, and as it supports different things. We talk about Brownian movement, which supports gaseous molecules. You know that as solid, the molecules have limited movement. It is not that they don't move, they vibrate, all right, about a fixed midpoint. In liquid, they move more freely. That is why they can take the shape of any container. But in gas, they move so fast that you have to compress them. They move so fast that you have to compress them. That's in gas. What will we talk about? That's molecular theory. Waves. We talk about waves. We talk about sound. We talk about reflection of light. Reflection of light is called rectilinear propagation of light. It causes shadow. It causes eclipse. Eclipse of the sun, eclipse of the moon. I've already told you in one of our lessons that the moon is not a source of light. Moon is not a source of light. Moon is an opaque object. Yes, so when you see in your options, which of this is a natural source of light, and they put moon, don't pick moon. No, moon is not a source of light. Moon only reflects the light rays from the sun to the earth. It's a reflector, it's like mirror. It does not allow light particles to pass through it, it will reflect it. So note that. Then refraction of light, that is the bending of light or any wave. The bending of wave has moved from one medium to another. That is why when you put a ruler inside the glass of water, transparent glass of water, the ruler appears bent. That's refraction. Then we have dispersion of light. That's where you have several colors. The rainbow colors is as a result of dispersion of light, where a light ray is split into several parts. Then this aspect that we have not touched is just about, I think, 4 topics here: electrostatic, current electricity, magnetism, then alternating current, and atomic physics. Those are the topics we have not explored really. So I will need you to go through electrostatics, electricity in general, and then atomic physics. Please, it's very important that we go through them. But I know that the bulk of the question will always come from those aspects that we have mentioned earlier. But then that does not mean you cannot go through. If you are a science student and you are pursuing a course in electrical engineering or mechanical engineering, of course, you won't have problem going through electricity. Electricity is an interesting topic, very interesting. It's wide, but you just need to know that V equals IR, of course. That is Ohm's law. Ohm's law states that V equals IR. And you also have an addendum to it. If you have V equals I plus I into R plus R, where you have what we call internal resistor. You can have internal resistor, then you are going to have I is equal to E over R plus R, something like this, where your E is called EMF. EMF is referred to as electromotive force. Electromotive force. Your V is the potential between two parts when that source of light is not supplying electricity. But if it is supplying electricity, you have to consider the internal resistance, and that is when we have electromotive force. Electro means electricity. Motive from the word movement. There is a force that is pushing all those electrons around the circuit. All right. A simple setup of electric movement, the diagram for it is called a circuit. And what else can we talk about? Of course, electromagnetism. We have that there is a magnetic effect that can come up as a result of electricity. A special magnetic effect that can come up as a result of electricity. It is called electromagnetism. Under electromagnetism, we talk about a lot of things. We talk about shunting, we talk about transformers. All these things has application. Shunting, transformers, we have secondary voltage, primary voltage under transformers, we have step-up transformers, step-down transformers. Wow. There's a lot of things to consider here. Physics is a very interesting topic. Then electrochemical effects. And for those that are chemistry students, you won't have issue with this, electrolysis. Yeah, you won't have issue with electrochemical effect. It's more or less like electrolysis. With the concept is that substances conduct electricity when electric current is passed through them. An example is your blood vessels. You yourself, you conduct electricity. That is why when you hold the tip of a live wire, you get shocked because some electrons are passed through you, and you conduct because you are not a pure person. You are not a pure substance. You eat, food that contains salt, and you know that salt can easily dissociate into sodium ion and chloride ions. So when an electron passes through, there are charges in your body that will pick it up and transfer it. And that can easily lead to a lot of ion reaction. You can have electrochemical reaction in your body. So please note all these things. You need to note all these things. So I think at this point, I've mentioned some basic things that you need to note as a means of revision. Let me wait by to see if there's anybody that has any question. Anyone with any question? I think it was last week we were discussing the concept of what was that we were discussing? I wanted to remember where I was giving definition of a particular concept. Moment. Yeah, moment. I remember now. We're discussing the concept of moment. Moment says that is a product of force and distance from the point of application perpendicular distance though, from the point of application of force to the point, from the point of application of force to the point of action of the force, that is moment. Moment is different from momentum. I think I was able to put, because those words sounds alike, but they are not the same. Moment is product of force and perpendicular distance, while momentum is product of mass and velocity. I remember we gave this distinction the last class. So I'm trying to work within time. I want to know, I think we have about 3 or 4 minutes left here, I guess. So any question, you remember clockwise moment is equal to anti-clockwise moment. Under momentum, we also have elastic and inelastic. Elastic if they both move together, inelastic if they move with different velocity. So all these are what you need to watch out for. Let me see if there's anybody left. Okay, see ya. Okay. I think those are the major things you need to know. Okay. I think we are done really. And if there are questions you cannot solve, please reach out to me on the platform. So far, so good. Vectors, we dealt with vectors. I knew we dealt with vectors. Yeah, vectors. We discussed vectors. I told you that vectors, combination of 2 or more vectors is called resultant. When you want to add 2 or more vectors together, it is called resultant. So it depends on what you need to do. You can resolve a vector into vertical and horizontal distances, or into vertical and horizontal vector. You can resolve it, in different other methods. You can find the negative effect of a resultant. Okay. We've done pretty well for ourselves, covering at least, I can say, 80% of the topics. If you are 100% sure of those 80%, then you don't have anything. You can't have less than 80% in any good exam, for which I know these are the questions, these are the hot topic areas. So let's hope for a good score between 80 and 90 over 100 in physics, which is good enough for you. I want to stop here, hoping that if there's anybody that wants to ask any question, you are free to hit me, and it will be fine. So Afiz, you are welcome back. May I know if you have any question in the next 2 to 3 minutes? All right, so if there's no one having questions, I think I would just say I wish you the best of luck at this point. Hopefully you do well in your exams, and we'll have cause to celebrate your, several individual results, good ones by God's grace. So let me just let you go and do your final revision on your own. If there's any question you want to ask me, you are free to come up and I'll attend to it. So let me say thank you very much at this junction. Wish you well and best of luck. Bye.